Hey guys, it's Mrs. Diaz here. We are going to go over some inverses. So if you look at homework 4.3.6, inverse trigonometry. First, they want you to sketch the graphs of sine, cosine, and tangent, identify the domain and range, and then on the side here, you have the inverses. So I'm going to go ahead and sketch these functions just because it's a good reminder of what these functions look like. So sine has a coordinate at the origin, has a maximum of 1 and a minimum of -1. And it's going to go up, it's going to come back down, it's going to go down to the min and then back up. And it creates this curve, this almost like this wave, that's going to continue forever, up and down, up and down, up and down. So we can say that the domain is all real numbers, and then the range is going to be from -1 less than or equal to y less than or equal to +1. So -1 to +1. And we can, in fact, equal those coordinates. So that's why we have the equal sign on the y. So there's our domain and range for sine. I'm going to go ahead and do cosine next. And cosine also has a max at 1, min at -1. This time, however, the coordinate for cosine intersects at 0, 1. It's going to come down, down, and then back up. And I'm going to go ahead and do it on the other side too. And it's just going to continue in this fashion. Again, it's like a wave, so it is going to continue forever in both directions, meaning that the domain is all real numbers. And the range, again, -1, less than or equal to y, less than or equal to 1. So you'll notice the domain and range are exactly the same for sine and cosine. However, they have different y-intercepts. So keep that in mind, different y-intercepts. Tangent, last but not least, tangent is definitely a weird function, but tangent has these asymptotes. And it's almost like it has the same little piece, almost like a cubic function, that's just going to repeat over and over and over again. And tangent's domain, I'll write it over here. Basically, the domain is everything except for where the asymptotes are. And that very first asymptote, the very first positive asymptote, I should say, is at pi/2. So we say x does not equal pi/2 plus or minus n pi. And the reason for that is because the next asymptote is going to be at 3 pi/2. So the distance between pi/2 to 3 pi/2 is 2 pi/2, which is the same thing as pi, which you see right here. So that's where that pi comes from. And then n means any integer, any number, any whole number. It can be positive or negative. Now the range is really nice. The range goes from -infinity all the way to +infinity. So that's y is in the reals. There's our domain and range for all the 3 trig functions. You will need to know these for the test, so make sure you have, you're feeling comfortable with these. Okay, now let's talk about the inverses. So remember, in order to have an inverse, you have to have a one-to-one function. And do you remember what one-to-one means? It means injective. The function must be injective, one-to-one. So, to be injective, you have to pass the horizontal line test. So basically, I'm going to take sine from this point to this point, and that piece right there is going to be one-to-one. It's going to be injective. So if I want to graph this piece, take the inverse, well, I'm going to take these coordinates. Now we didn't label these ones, but this is pi over 2, and this is negative pi over 2. This would then be pi, 3 pi over 2, and then 2 pi, because we know a full period is 2 pi. So I'm going to take this coordinate 0, 0, and take the reciprocal, which is still 0, 0. And I just said reciprocal, but I meant to say inverse. So if we have 0, 0, the inverse is 0, 0. Now take a look at our range is from -1 to 1. That's going to be our domain, -1 to 1. We flip the domain in range. So the domain is going to be negative pi over 2 to positive pi over 2. Since that was the domain, it's now our range. Notice this coordinate is pi over 2 comma 1, so the inverse would be 1 comma pi over 2. Over here, this is negative pi over 2 comma negative 1, so the inverse is -1 comma negative pi over 2. And then we're going to create a curve, and that represents the inverse. And actually, I'm going to change it a little bit. You see how this one goes like that? Let me clean this up a little bit. I don't really like the way I did the curve. Let's try that again. I actually want to go the opposite direction like this. There we go. That's what I want. You see how this is like under and over, and now it's over and under. I want to just do it a little bit like the opposite. Basically like go like this. All right? Because if you guys remember, inverses are reflections over y equals x. Over the line y equals x. That's pretty important. We've talked about inverses in the past, and you talked about them in Algebra 2. So you know that inverses have to be injective and have to reflect over the line y equals x. Okay, now let's do some cosine. Now the same is going to apply for our domain and range. Domain is now -1 to 1, since that was the range. And then I'm going to take negative pi over 2 to pi over 2. And come to think of it, oh no, how do I go back? There we go. Come to think of it, this is going to be a little different. Cosine's not exactly the same as, I keep doing that, as our sine graph, because I want you to notice, we're going to take a piece that's 1 to 1, or injective. Well, this time I want to take this piece here. Do y'all see that piece right there? That's going to pass the horizontal line test. This right here is going to be pi. So, and this right here is pi over 2. So instead of negative pi over 2 to pi over 2, I'm going to do 0 to pi. 0 to pi. Because I'm going from this coordinate to this coordinate. And that domain is 0 to pi, which then would be our range, 0 to pi. Cosine's a little bit more challenging. Okay, so notice this coordinate is pi over 2 comma 0. So the inverse would be 0 comma pi over 2, which is halfway between 0 and pi. Notice this coordinate is pi comma -1. So the inverse is -1 comma pi. And then this coordinate is 0 comma 1, so the inverse is 1 comma 0. And then cosine is going to look something like that. There you have it. There is cosine. Now we got one more, and that's tangent. So tangent has this nice range of all real numbers. So that means the domain is going to be all real numbers. Now, for our domain on the original, this is negative pi over 2. So I'm going to go ahead and say that our range is negative pi over 2 to positive pi over 2. There's our range because it was the domain. And now let's plot some points. So here's a point 0, 0. Well, the inverse of 0, 0 is still 0, 0. If you were to think about like this one right here between 0 and pi over 2, that's pi over 4. I know tangent of pi over 4 is 1. So the the inverse of pi over 4 comma 1 is 1 comma pi over 4. So 1, let's say this is 1 comma pi over 4. And then the negative side, negative pi over 4 comma negative 1 would be negative 1 comma negative pi over 4, which is going to create the curve. This is going to create some asymptotes because we have asymptotes at pi over 2 and negative pi over 2. So there you have it. Those are the inverse functions. That's what they look like. Of course, how do we apply this? And what are we going to use this or see? How would we see this on a test? Well, let's look at some examples here. Remember that we had to restrict the domain. So if you go back to what we did earlier, we had only a little segment that we were thinking of. Because remember, it has to be injective. So to restrict the domain, I'm going to write this on the side. Sine inverse is going to be restricted in the first and the fourth quadrant. Okay? Cosine inverse is going to be in the first and second quadrant. Last but not least, tangent inverse is also going to be like sine, which is the first and the fourth quadrant. These are our restrictions. What that means is when we do sine inverse of root 2 over 2, we're trying to figure out where on the unit circle is sine, which remember, that's the y-coordinate. Where is the y-coordinate root 2 over 2? Well, we can only look in the first or fourth quadrant, and because it's positive, I'm going to look in the first quadrant. Root 2 over 2 is going to be right here, and that's at pi over 4. That's the only place that we can choose because it is inverse. It is restricted. Let's try sine inverse of negative root 2 over 2. Well, negative root 2 would be in the fourth quadrant. That's going to be 7 pi over 4. And remember, if you forgot your unit circle, I would suggest going back and practicing 7 pi over 4 is the answer, or the other correct answer is negative pi over 4. That's because we went pi over 4 in this direction, but going in the clockwise direction, this would be a negative pi over 4. And this is positive pi over 4. So keep an eye out on the negatives because that is actually correct as well. Let's try cosine. Where is cosine 1/2? Well, remember cosine is the x-coordinate. So where is cosine 1/2? Well, we are looking either the first and second. Since it's positive, I'm looking in the first. And I'm going to look at the one that's up here because that coordinate is 1/2 comma root 3 over 2. And that's at pi over 3. Pi over 3. What about where is cosine negative root 3 over 2? Well, cosine is negative in the second quadrant, and it's going to be this one here, which is 5 pi over 6, or actually for this one, I think they'll leave it as a positive instead of a negative. So I'm going to leave it as 5 pi over 6. All right, there you have it. There's a few examples here. We definitely can practice more inverses in our Zoom conferences, but I'm going to stop there and again, hopefully we'll talk to you soon.